let me start by introducing me a little. As he said, I'm one of the co-developers of TurboGears. I'm currently the maintainer of Beaker, which is a framework for caching and session that you might have used on Pyramid or Bottle or other system where it's commonly used. I'm the creator of DuckPy, which is a JavaScript interpreter for Python, Depot, which is a file storage framework for web applications. And I contributed to many different kind of projects in the Python environment world, mostly related to web applications. One of the things I never worked on until like 6 months ago was a compiler and a template engine. And actually, I've been involved in Kajiki, which is both a compiler and a template engine. And I decided it was a really good thing to do to talk about how the templates ecosystem, how template engines and things like that work, because it's something that we probably use at least once in our lifetime. We might have used the one that the web framework provided for us out of the box, or we might have used something by itself because a colleague suggested it was a good tool for that specific problem. But it's something we always use without asking ourselves too much how it reaches the goal, how it works, why it was created, and things like that. And actually, one interesting thing is that if you go open the box and look inside the template engine, they are really, really different. They work in so many different ways that they are actually totally different softwares. There are some that work in a way that it resembles a pure compiler, okay, we're creating an intermediate representation of your code, and some that are just a bunch of regular expressions that throw in surrounding boxes around the text you wrote and things like that. And working on one has been really interesting for me, so I thought that it was cool to share that experience with you all. What we have in Python is a pretty rich environment for template engine. There are many of them. Probably the most used one is the Django template engine because it's built into the most used web framework. But there are many also outside of the Django world, which the most famous probably are Genshi, Mako, Jinja. Okay, you probably use one of those in your daily development. And they are actually, you might think that in the end they are all template engines, but they are really, really different. And I try to categorize them somehow. And you can see that, for example, near some of them, there is written that there are text or markup engines, and there are streamed or compiled engine. What does it mean? It means a compiled engine is actually a system that reads your code, translates it to another representation, and in the end generates a code for your own language, in this case Python. So in the end, it compiles your template to Python. It actually transpiles it, if you want to be precise. But in the end, what it means is that you get some Python code out of your template code. And while for the stream template engine, in something totally different, it still converts your template to an intermediate representation. But instead of converting it to Python, it interprets it on the time. Like when you start rendering your template engine, you have something like a virtual machine that interprets the code for your template engine in some kind of language that the template engine developers invented for their own use. And what does it mean? It means that, for example, as out of the execution of a Jinja template, I get Python code. The Python code cannot easily modify itself. Okay, well, you can, but it's not something you do on a daily basis. While in Genshi, for example, I have an intermediate language which resembles a lot the DOM of your document, if we are talking about HTML documents. And you can actually modify the template itself from inside the template because it's streamed. So it means that part of the template you are going to modify has not yet been executed and has not yet been analyzed by the virtual machine. So it can be changed before it arrives to the execution engine. So you can have some code that actually changes a part of the template itself. okay? While in Jinja, that's something you cannot do. Well, you can have blocks that get injected inside another location or things like that. But you cannot have some code that says, hey, replace all the span in my code with divs. Okay, while in Genshi it's something that you can, and usually Genshi developers know how to do and sometimes do. And there is a difference between text engines and markup engines, which is the difference is that text engines don't care at all about what they are trying to compile, to render. That's just text for them, okay? You could write JavaScript or HTML or CSS or whatever you want inside the Jinja template, and Jinja won't care at all. It will execute its own directives and will provide some kind of output. If that output doesn't make sense, it's your fault. It's not Jinja's fault, okay? While for Genshi and Kajiki, the input is actually validated, it's understood by the engine itself. So he knows that you are writing HTML, for example. So if you did something that HTML doesn't accept, the template engine won't accept it too. And we will see what does it mean, because there are some slides specific on this problem. So Kajiki, it's a template engine you probably never heard before because it's pretty young and has not been much presented around. I think this is the first presentation about Kajiki, even though it's not so recent. It has been created a few years ago. And if I'm not wrong, it's been created inside SourceForge for their own use. But at the end, they never used it because they went with Jinja. But they experimented with Kajiki before doing that. So why one more template engine was created and why I got involved with this template engine? Everything started from TurboGears, okay? The TurboGears team really loved Genshi. Most of TurboGears users love some of the features of Genshi. The fact that Genshi would understand your HTML, that actually a Genshi template was perfectly valid HTML, which means you can open a Genshi template inside Dreamweaver or something like that, change its look through the WYSIWYG editor, and then save it again, and it's still a valid Genshi template. Okay, something you can't do with Jinja or things like that usually. Because the directives for Genshi are just attributes of your tags. So as far as the editor maintains the same attributes you had before, your template is still valid. And the fact that the directives were attributes of the tag made it really small and easy to understand the structure of your template, because what you saw was just HTML without any specific surrounding code. For example, if you look at a Mako or Jinja template, you see code specific to the template engine mixed within your HTML. And that somehow breaks the flow of your HTML. We love Genshi so much that since version 2.2 of TurboGears, it got included in all projects. In TurboGears, you can choose to switch template engine when you create a new project. You can say, yeah, I want to create a new project that uses Mako, a new project that uses Jinja, and so on. And the framework tried to support them all in the pluggable extensions, in the TurboGears admin, and whatever. But we thought that at some point we needed the default one because it made easier the life of people that needed to write pluggable application and extensions, because they knew that they had that template as a fallback. They didn't have to implement every single template engine existing in the world to make sure that the users could use their extension. And so even if you started a project with Jinja, you will get a Genshi template engine support, so that if any extension used Genshi, which was the default, you will still be able to run them inside your application, even though they were implemented in a different template engine. And what happened is that actually like 2 weeks after we released 2.2 with Genshi as the default engine, someone wrote on the TurboGears mailing list that Genshi was going to be deprecated. and maintained for the next few years. And this is how we felt. We just found the perfect template engine, and we lost it the day after. So what could we do was jump in and start maintaining Genshi ourselves, which was something that we thought about. We had a look at the Genshi code, but there were a few things that we weren't not sure about. For example, Genshi is really complex. The fact that it has built-in interpreter, an intermediate language, it's like writing a new language, okay? It has a complexity that by itself we didn't want to tackle just for a template engine, okay? And actually all this complexity was due to some features while streaming and the powerful inheritance system of Genshi that no one understood. 90% of our users couldn't understand how inheritance in Genshi actually worked. And I'm sure that they have good reasons for this, because it actually works in the opposite way that everything else works in inheritance systems. I mean, usually you use that a subclass specifies the behavior of the parent, while in Genshi is actually the exact opposite, okay? The parent is injected inside to the child, and the parent can have a statement that says, hey, inside myself, put the content of my child. So it's like you have a method where when you subclass, that method is not specifying the parent one, but the parent one replaces the children method, the child method, and it can have a statement that says execute the child method. So it's totally the opposite that you are used to. And this is done because you can implement powerful matching and replacement through XPath. So you can actually inherit and replace every single piece of your template. You can write really super complex expression that change anything of your template itself at runtime. It was something that users didn't know how to do. They just got confused out of it. And in the end, they never needed. So it's something that we didn't feel it was fine to face all that complexity for a feature that no one at the end used it and was actually not understood very well. And at the same time, as I told you, there was a guy that was experimenting with a new template engine, and I think he was already working in SourceForge at the time, but I'm not sure. And he was one of the contributors of TurboGears and said, hey, I did this. It's just an experiment I did on a fly through the ocean and so on. But it's pretty cool, the idea. It's fine, it's fast, and so on. And we say, wow, this is exactly what we were looking for. And this is how Kajiki looks like. Okay? If you ever worked with Genshi, you will see that it's actually exactly the same. You cannot distinguish the two engines apart from some specific things, okay? So you see what I was trying to tell you, that the template itself is actually, in the end, the HTML itself, okay? We have the directives like the for or replace the content that are inside the HTML itself as attributes of my tag. That by for means repeat this list item for fruit in fruit, okay? So I don't need to wrap the list item with specific code. I just add an attribute to the item itself, and that attribute can say, show this tag only if, or repeat this tag, or strip this tag if, or whatever, okay? But they are attributes of the tag itself, so they get conserved by any editor you use. Usually any editor that understands HTML or XML is able to work with the engine itself without causing any damage. And the directives that Kajiki supported were in the end the same directive as Genshi with one specific change which solved our major problem with Genshi, which was the inheritance. The inheritance system implemented in Kajiki was actually based on blocks, which is the same of Jinja, if you ever used Jinja. So it was easy to say, hey, just put this piece of the other template inside the child, okay? So it was easy to work with it, and everyone understood how it works because it's how we are used to work with inheritance, okay? So we just took the child that inherits from the parent, and the child could say, put here a piece of the parent, and not vice versa like Gensh did, which is actually what everyone is used to. And it's far less powerful because you cannot do strange dark magic things replacing parts of your system to extract expressions, but in the end that was something that no one ever did. And how Kajiki works is actually by parsing your template and then converting it to Python code. And when I mean converting it to Python code, you will see that I really mean it. You get out of a Kajiki template a pure Python code, and you can even see the code itself and change it in whatever way you want. And when you are rendering the template, you just execute that Python code. And the variables you pass to your templates are just the local and global variables of your template code too. The way this is implemented is by creating a generator which somehow resembles the DOM of your template. So it's a generator that inside might iterate over another generator which represents a nested tag inside the parent tag and things like that. And this is actually pretty fast because iterating over a generator has little memory constraints. This Python itself optimized that. And it's pretty fast because if you iterate from something like a join, you never get out of the Python interpreter itself and never get out of the C layer of the Python interpreter because you are just saying, passing the generator to the join, and then the join switches to the interpreter code, to the C layer of the interpreter code, and starts iterating at C level. It doesn't have a context switch to go back at Python or run A4 and step in back again inside the virtual machine of Python and things like that. You enter into the virtual machine once and you get out only when you finished running the whole generator. The architecture of Kajiki is actually pretty clear and simple. It is divided in three major components. One which is the parser, which is not even implemented in Kajiki itself. The smart move was that Rick, the guy that created Kajiki, in the end just used the Sax parser to understand the content of the template. So we were pretty sure that it worked, okay? And it navigates the DOM that Sax created, and out of the DOM it creates an intermediate representation, which is a tree of nodes that know how to build the code. And then out of the intermediate representation, the Python code is generated. And this is the Python code you will get. This is actually the Python code of the real template itself. So you can see that this was the template where we have the list item with a 4. And this is the template, the code where we have the 4 that yields the list item, okay? And when we render it, we get actually the output we would expect. And the way Kajiki is implemented makes it pretty fast, so fast that it's actually faster than most of the template engine actually available in Python. Jinja is still faster because it implements many optimization, but it's fast enough to make it usually faster than Mako, for example. And the fact that it's just Python code means that you can even apply dark magic to your Python code. For example, this is a small mad science experiment where I use Cython to compile my Kajiki template to something that is actually executing pure machine code. So what I get out is actually something that works, even though it was a huge hack and pretty complex. And without changing anything, just running Cython without decoration and anything else, was that he actually has been able to speed up my template. Okay, so with minor changes, it could probably be something that we can achieve inside Kajiki itself. And the fact that it's pure Python code makes it really good for debugging, because you can apply all the tools you are used to in Python itself. For example, this is the Werkzeug debugger. If there are Germans, they might correct it now. I say it Werkzeug. And you see that whenever there is an exception, like in this case a zero division error, the debugger is able to point me to the template code, to the HTML code that generated that exception, not to the Python code. Because Kajiki rewrote the bytecode by pointing it to the right location, lines, and whatever code and source that caused the error. And if you wrote a syntax error inside your template, Kajiki is able to showcase it to you because it actually generates a Python code. So the syntax is the Python syntax. And it even can show you an error where you did the error for real. And another good thing is that as it uses an HTML parser, it works with perfectly validated templates. So if my template is not well formed, like in this case, I opened a list item and I close a span, Kajiki will tell me, hey, you closed the wrong tag. See, it said mismatched tag. You opened the list item and you closed the span item. This is something that no other template engine apart Genshi does, and which is usually very good because it's something that you only discover at runtime when you deploy your application and you see, hey, why it's broken the web page. And also escaping is handled for us because Kajiki understands the template, understands where HTML should be escaped. It can apply escaping. Like in this case, I wrote Apple with the angular brackets, and you can see that Kajiki escaped them for me because he knows that there shouldn't be an angular bracket inside a content, a text node of my template in HTML. And also, as it understands where there is content and where there is structure, the tags, it's able to apply translation for me. Anything I write inside my code, inside my template code, any single text node is automatically wrapped in a get text call for me. So if, for example, I wrote this template, I like through it, okay, it will be automatically translated, the I like phrase. So in all the other template engine, you usually need to specify translate this, you fill your template with a lot of get text calls here and there and things like that. While in Kajiki, this is automatically done for us. And you can just say, hey, extract all the string that I should translate. And also, one of the last things that you can do as you understand the structure is minifying our code. So if I wrote HTML and I want to shrink it to the minimum, I can say to Kajiki, hey, just strip all the white spaces from my code so I get minified HTML. And you know what it has to preserve and what it has to complete. Last part is that, of course, I told you a lot about how it works with HTML. And of course, it works also with pure text. So if you need to work on CSS or JS or whatever, you can do that. So feel free to try Kajiki. If you find any issue, if you have problems, it's still a young project, so open the issue on GitHub, especially feedbacks on documentation are appreciated.